All right, geometry notes 1.2. First, we're going to start with the ruler postulate. And postulate is just something, it's kind of like a hypothesis or an educated guess. It has been tested, but it's not scientifically proven. So don't kind of get caught up in that whole what does that word postulate mean. It's just kind of think of like as a rule. So what that means is that the points on a line can be matched 1 to 1 with the real number. The real number that corresponds to a point is the coordinate of the point. And this is just real simple. It's just a lot of big fancy words, and all it means is if you have a point here on a line and another point on a line, that remember like the old school number line that you used to count, like this would be 0 and this would be 5. So these are actually the names of the points, and these numbers are the coordinates. And that's all that means. Okay, now what else is that the distance between points A and B, written as AB, is the absolute value of the difference of the coordinates. So this is all about just measuring distance, like you're using a ruler. That's why it's called the ruler postulate. When you use a ruler, you measure from like 0 to 5, and that would be 5 inches. But you don't always have to start with the 0. You know, you could start at 5 and go, okay, this goes from 5 inches to 10 inches, and you would still say that's 5 inches. So it's just talking about the difference between the 2 points. So if we had a line here, and we had our points, and this was at 0, 5 again, and we wanted to find the distance or the length in between there. This would be segment AB. All we would do is take the absolute value. So to find the length of AB, the absolute value of 5 minus 0, okay, is 5. And remember, all absolute value means right here is that it's not negative. Distance can't be negative. If you move forward or backwards, you're still covering ground. Your feet are still moving, so you're not going to have any negative lengths. Well, we previously talked about segments, so now we're going to talk about adding segments together. So when you have any 3 points that are collinear, you can say that one point is between the other two. And we're really going to talk about the importance of this word between. Between just means it's in between. It does not mean it's in the middle. So those two words are actually very different for us in geometry, and they make a big difference. So you need to know the difference in the word between and the middle. So what we can say here is if we want to draw a line with some points, and we could have another point over there, is that we could say, okay, that B is between A and C, because they're all on the same line and B is in between it. We don't know if it's the middle or not. Even though if it looks like it's the middle, it's not the middle. So you're going to learn that a lot, is that if the proof is not in the pudding, you can't assume it. So no assumptions. We don't know that's the middle, and we're going to talk about in just a little bit how you know that's the middle or not. And since that point E is not on the same line, then E would not be between A and C. Or you could say B and C, or any of the 2 points. Now what we can do is we can add them together and find the length of certain segments. So in the segment addition postulate, if B is between A and C, kind of like right here, okay, that would be a picture of B in between A and C. Then we can say that AB, okay, and that would be this piece right here, AB. If we add it to the other piece, okay, this piece, Then if we add those two pieces together, what we're going to get is the whole entire thing. So we're going to get a length of AC. So I always just think about this as two pieces. All right, they equal the whole thing. So think about if you were to break your pencil in half, or any amount of pieces that matter. If you would break your pencil and if you would tape it all together, you would still end up with one pencil. And you can say also that the converse of this is true. And the converse is a word that we will become more familiar with as the year goes on. But converse just means that you can flip this sentence around. So you see how you have here that if B is between A and C, then. So we kind of have a hypothesis. We have a if, and then we have a conclusion, then. Well, this situation also happens to be true in reverse. So if you have AB plus BC is equal to AC, then you can go ahead and say, okay, then that means that this letter B is between those other two. And the way a picture looks for that is, again, if we have our letters, B is between A and C. All right, this distance in here, this is AB from here to here, and then we have BC, and this whole thing is AC. So if you add the two pieces, then you get the whole thing. So now some examples of how you would apply the segment addition postulate is this. Look at this example 1 right here. It says find the indicated length. So we have to find this as find GJ. Now what I also want you to start paying attention to is how this is written out. Anytime you see just the letters, any letters, and they don't have a bar over the top, this is going to represent length. Anytime you just want to refer to the segment, the name, just using the name, you would then put the bar over the top. So this is read as segment GJ, and this is the length of GJ. And I'll just discuss that over and over and over and over again, that there is a difference between writing this and writing this. Okay, so find the length of GJ. Well, first you want to ask yourself, is that the whole thing or is that a piece? So if you look at GJ right here, that's going to be the whole thing. And sometimes it's good to write, okay, is it the whole thing? Is it the piece? So if it's the whole thing, if we want G to J, we're just going to have to add those two together. So the two pieces equal the whole thing. So to write this properly, GJ, we don't use the segment bar because we're giving a specific value is 16. That's your final answer. Okay, on the other one, ST. So ST is right here. Well, if you look now, all we want is a piece. We have the whole thing as 37. RS is already taken up 18 units, so it wants to know, okay, how much is left? If you go 37 minus 18, you get 19. So here, ST is equal to 19. So you can kind of see the difference here. If you have the whole thing, if you're wanting the whole thing right here, you're going to add. If you're wanting a piece, you subtract. Congruent segments. So line segments that have the same length are called congruent segments. And remember, I told you you can't assume that pieces, that points are in the middle unless you know for sure. And so this is how you know for sure. If you have a line, and let's draw, a segment and another segment, A, B, and C, D. So if we have these two segments and we want to know if they're the same length or not, the way in geometry that we show that they're the same length is we put these little dashes or tick marks, okay, on top of the lines. So you'll hear me call it a dash or a tick mark. What that means, these two little lines here, means congruent. So now we can say that the lengths are equal. So the length, remember when we're talking about length, we do not use the segment bar over the top. So the length of AB is equal to CD. Okay, we don't use a bar with length. And if I just want to talk about the segments, I can say that segment AB is congruent to segment CD. Okay, and these are just referring to the segments as just their names. And so that's when we do use the bar over the top. And as you can see here, this might be something new to you, this symbol, the equal with the little squiggly, I call it, on top. Okay, this means this is congruent. And we're going to use this a lot. Okay, so that symbol is congruent. Alrighty, thank you.